3.2 applications of Venn diagrams. You see a couple of examples here, but this one right here is the one that you've seen the most. You've got two sets, set A and set B. You've got overlapping circles, and so usually there's something in the overlap, and a lot of the times we're concerned about this region right here, but not necessarily. And that's when it gets difficult, is when you're concerned about some other location other than the overlap. In the second picture, you don't see this picture very often, but this one is a picture of disjoint sets where there is no overlap. The overlap is the empty set. And then the next one, you hardly ever see this one. This one is showing a subset. Set A is completely contained within set B. So A is a subset of B. I think that symbol looks kind of like a C, and so sometimes I'll read it as A is contained inside of B. Think about it that way if you want to. Example 1 says draw Venn diagrams for the following. And what I would highly recommend you do is draw them all kind of the same way at first. You draw like a bare bones problem, and you see there's two sets. There's set A and set B. And so I would draw a circle for A and a circle for B overlapping like this. And then you draw a box around it. If you forget to draw the box, it will be wrong, okay? So draw the two circles, draw the box, draw it the same way pretty much every single time. All right, now, remember what that apostrophe means. That means not A, intersected with B. And so in this one, you can probably just look at it and figure out where I'm talking about. We want the region of this graph, region or regions, that is not inside of A and at the same time is inside of B. So you can probably see what that is, but I want to give you a method for anytime you can't see what that is. So I'm just going to number the regions. 1, 2, 3, 4. There are 4 separate regions on this graph. And so I'm not gonna try to visualize. I'm gonna do an analysis on the numbers. So when I see not A and B, well, think about the numbers. Which numbers are not in A? Well, it's 1 and 4, right? 1 and 4 are not in A. And which numbers are in B? Right, 4 and 3, or 3 and 4, either way. So what I'm intersecting is those regions. I'm intersecting the regions 1 and 4 with regions 3 and 4. And if you look at it that way, you're like, well, and means both. So I'm left with just region 4. So I want you to neatly color in region 4. Now, I bet some of you knew that without doing that extra work, right? Yes? Okay. But that's the thing. It's going to get harder. You're not going to be able to just visualize every single time. So then the next one, it says not A unioned with not B. For some reason, unions are automatically going to be harder for you to visualize. So let's draw the same picture to start with anyway. We've got 2 overlapping sets with a box around it. Don't forget the box. I'm going to go ahead and label the numbers again. 1, 2, 3, and 4. Now, it's a good exercise to try to pick out which region you think it is, region or regions. Sometimes it's more than one. All right, not A or not B. Maybe you can do it, maybe not. But let's analyze this. Not A would be 1 and 4 again. We're going to union that with not B. Not B would be 1 and 2. So remember from last time, union means join. We want either region 1 or 4 or 2, I guess, right? 1, 2, 4. We would end up coloring inside all 3 of those regions, 1, 2, and 4. The only region we don't color in is region 3. So try to make it neat, try to make it nice. You're coloring in all 3 regions, 1, 2, and 4. I think that one's a lot harder to visualize. Questions before we move on? Number 2, draw a Venn diagram for this. And so now all of a sudden, you've got 3 sets. And so it's a slightly different picture with 3 sets. You've got 3 sets, so 3 circles. I would try to draw the same thing every single time. A, B, C, box around it. Box around it. Kind of looks like Mickey Mouse ears to me, I guess. It doesn't have to look like that, but I think that's the best way. All right, make sure you draw that box around it. Now, does anybody know how many different regions there are in this picture? Think about it this way. There are 3 sets, so there would be 2 to the 3 or 8 subsets. There are going to be 8 different regions of that graph. So I'm going to label those or number those regions. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And it doesn't really matter if you number them differently than me, if you use letters or different locations or whatever, you're going to have 8 different things. Doesn't really matter because we're all going to come out the same. All right, so let's analyze this. Parentheses means we look at that first. It's like order of operations. So inside the parentheses, I'm going to start with region B. Region B, in my picture, maybe yours is different. Make sure you do whatever's on your picture. In my picture, region B is 3, 4, 6, and 7. I have to intersect that with region not C. And so you look at not C in my picture, what numbers are not in C? Not C is 1, 2, 3, 4. Not C is 1, 2, 3, 4. Now again, that's in parentheses, so we do that part first. We're going to find the intersection. Remember, this stands for intersection or overlap. We want to find the overlap of those 2 sections. So look at what they both have. They both have a 3 and a 4. I think that's it. So 3 and 4. Now we can come down here and do this union. All right, we're going to do this union now. And let's look at not A. Not A would be 1, 4, 7, 8. I try to put them in numerical order. I just think it's organizationally easier, so we're all on the same page and we'll all have the same thing. I've got 1, 4, 7, 8. Those are the things that are not in A. So remember what happens when I do a union. When I do a union, I'm going to join. I'm going to join them together. I'm going to take all of them. I'm going to have a 1 and a 4 and a 7 and an 8 and a 3 and a 4. 8. I'm going to have 1, 3, 4, 7, 8. Now that's not the answer. Technically, I should have probably, put it in set notation. If I was going to write it, better, I need to color those. I need to color those regions. So I've got region 1, 3, 4, 7, and 8. So let's do that. Do a nice job. Do it neatly. One, 3, 4, 7, 8. Those numbers don't really mean anything. They were just to help me get to the answer. The answer is the picture. Now we're going to start solving some problems. Number 3 says a researcher collecting data on 100 households finds that 76 have an Xbox, 21 have a PlayStation, and 12 have both. Use a Venn diagram to answer some questions. All right. So the answers to these questions are not obvious at all. That's why a Venn diagram is going to be useful for us. It's going to make it a lot easier to think about. Okay. So if I'm going to use a Venn diagram, first thing you'd want to identify is how many sets there are. Okay. In this problem, we're talking about people with an Xbox and people with a PlayStation. So I see two sets. And so I'm going to draw the same picture. I'm not going to label them A and B. I'm going to label them X and P. I want to be very descriptive. I want to be descriptive enough so that I'm clear and can follow my work. Now, I'm not going to label the regions 1, 2, 3, 4 like I did in the previous example. I'm going to label them with the numbers that they gave me. Okay? And here's a pro tip. The best number that they can give you is the overlap. So the best number that I see on this problem right now is 12 have both, because I know exactly where that goes. 12 is both, so 12 is in the overlap. Put a 12 in that overlap. Okay? Now, here's where people mess up. Trust me on this. People will look at this 76 and they'll try to put a 76 here, but that's wrong. Do not put a 76 there. If you put a 76, erase it. It's wrong, because the number of people that have an Xbox is represented by this circle. And this circle now says that 88 people have an Xbox. Okay, so that can't be right. If you think about it, we've already represented 12 of those 76. So that means there must be 64 other people. In other words, those 64 people do not also have a PlayStation. 12 people have both of them. 64 just have an Xbox. Okay, now we're going to do the exact same thing on this PlayStation. We are not going to put a 21. We are not writing a number 21. You can say, well, it's 21 minus 12, or it's what number plus 12 equals 21. This has to be 9, I believe, right? That number has to be 9. Okay. So what about the 100? Well, that 100 is total. And so again, people that don't really pay attention to what they're doing are going to put 100 out here, but please don't, because that's wrong. Do not put 100 out there. That is not right. 100 needs to be all 4 of those numbers added together. Okay, this number plus this number plus this number plus whatever this number is would add up to 100. So if you think about it, we've got 76 plus 9, that's what, 85? I see 85 on the board, so that means there must be 15 others. Okay, all 4 of those numbers now add up to 100. That's everybody in this survey. The 15 represents the 15 people that don't have either one of the things. Neither have an Xbox nor a PlayStation, nor both, I guess, right? Once you get these numbers in, it's pretty easy to answer the questions. How many do not have an Xbox? Okay, so we're looking at not X, right? Not X. So look at the numbers that do not have an Xbox. That would be, what, 9 plus 15 is 24. 24 people do not have an Xbox. How many have neither an Xbox nor a PlayStation? Well, that's just 15, right? That's the people that don't have either one of them. How many have a PlayStation but not an Xbox? So PlayStation and not an Xbox. Looks like that. PlayStation and not an Xbox. So if you want to do our analysis, PlayStation is 12 and 9. Intersect that with not an Xbox, which was 9 and 15. But you probably don't need to do that. It's 9. Okay. The intersection is the number that's in common for those two. 9 people. A lot of times you can just look at the picture. 9. Questions now. These problems look easy when I do it. You got to be able to do it. Union rule for sets. Draw a box around this. This is going to come up in a couple of different lessons, a couple of different aspects or problems, it's going to come up a couple of times. And the way I remember it, it doesn't look like something you have to memorize, but it's really pretty easy. I look at it as a double. This is a double. When I say double, I mean there's A and B. There's two things. And we're going to add a single plus another single, and we're going to subtract the other double. And the reason I say it like that is because those two doubles are interchangeable. And you could also write it like this. Instead of the union, write it as the intersection. And it's going to be the single plus the other single minus the other double. If I say and on the left, you say or on the right. If I say intersection on the left, you say union on the right. And both of those two equations are the same. It doesn't matter. They're kind of saying the same thing. It has to do with algebra. Think about adding and subtracting your terms around, but they're the same thing. So number 4 says use the union rule. So we want to know the number in the union right there, right? The number in E or F is how I read that. So the formula says take the single plus the other single minus the other double. So on the board we have a union, so then we need the number in the intersection over here. And it's very specific. If you don't have exactly that information, you cannot use the union rule. You have to have exactly that information. So in this problem, they give me the number in set E is 25. The number in set F is 40. And the number in the intersection is 10. 25 plus 40, that's 65. Minus 10, that's 55. So I like to write the answer like this. Number in the union equals 55. Okay. So then part B, it looks like you have to do something weird because this time we're asking for the intersection. But I don't really memorize this formula. I just remember it's a start with a double and I end with the other double. So it's going to be single plus single minus the opposite double. So I started with an intersection. I'm going to have a union over here. That's my formula. So the number in G, that's 72. The number in H, that's 30. The number in the union is 100. That's 102 minus 100, that's 2. The number in the intersection is 2. I like the union rule, okay? If you can't use the union rule, you have to draw a Venn diagram. So you've got pretty much those two tools. Either you're going to use a Venn diagram or you're going to use the union rule. You cannot use the union rule every time, though. You have to have that exact perfect stuff to use the union rule. Number 5. A group of 10 students meet to plan a school function. All are majoring in accounting or econ or both. 5 of the students are econ majors and 7 are majors in accounting. How many major in both subjects? Okay. So how many major in both subjects means we want the number that are in, what do we have? We have accounting and we have econ. I see 2 sets. So major in both subjects, I would say that as A and E, like that. That's what I'm trying to find, the number in accounting and econ. So what we could do is draw out a Venn diagram maybe. When in doubt, a Venn diagram is usually going to work. It says 10 students plan to meet, they're meeting a school function. All are majoring in accounting or econ or both. All right, so that just tells me that there's nobody that's doing neither. 5 of the students are econ majors and 7 are majors in accounting. How many major in both? That's kind of hard because really you'd have to use a variable here. So we don't know what's in both. That's our variable. All right. But what we do know is we do have information for the union rule, because the union rule says the number in the single plus the number in the single minus the number in the opposite double. And it says 5 students are econ majors, and it says 7 are majors in accounting. And the group of 10 students that are all majoring in accounting or econ, that's like the dead snowman. That's one or the other. 10 are in one or the other, so that's this right here. You've got 12 minus 10 is 2. So the number in the intersection is 2. So let's go back to the Venn diagram. I told you you'd have to use a variable. This is going to come up. This is probably the hardest part of the lesson, is when you have to use a variable. We don't need it, and we don't need to do that here because we can use the union rule, but I'm just saying, what if? What if you couldn't? All right. So here's how this would work. When it says 5 students are econ majors, you do not put a 5 here, because now it's 5 plus whatever x was. And if we know x is 2, that means that's telling me that 7 are econ majors. That's not right. But since this is a variable, what I can do is just put minus x here. And so if you think about that, x plus 5 minus x, the x's just cancel out, and that tells me there are 5 econ majors. And so in a similar way, when they tell me 7 major in accounting, I'm going to say 7 minus x right here. 7 minus x plus x equals 7. There's my accounting. And then they told me that that's going to add up to 10. And so what I would have to do in this problem, and what you will have to do on a later problem, is something like this. Those 3 sections are going to add up to 10. And so you can cancel a couple of x's. You can combine your like terms. 12 minus x equals 10. And once we ISO the variable, negative x equals negative 2, x equals 2. That's telling me my x right there is 2. And so I know you don't want to do it that way. And in this case, you don't have to do that way if you know the union rule. But if you don't know the union rule, then you can still do it this way. Let's move on. Number 6. Survey of 77 business students at a university produced the following results. 25 read Bloomberg Business Week, 19 read Wall Street Journal, 27 did not read Fortune, 11 read Bloomberg Business Week but not Wall Street Journal, 11 read Wall Street Journal and Fortune, 13 read Bloomberg Business Week and Fortune, 9 read all 3. And then they ask you some questions. There's a lot of information. Students really struggle with this one, okay? We're going to solve it with the Venn diagram. We only have 2 things. This lesson only gives you 2 tools to use. Either you draw a Venn diagram or you use the union rule. This is not going to be the union rule. Okay, it's going to be a Venn diagram. So we look at this problem. How many sets are there in this problem? 3. There are 3. We're going to have a set for Bloomberg Business Week. We're going to have a set for Wall Street Journal. And we're going to have a set for Fortune. And so remember, I draw my picture like this. We've got Bloomberg. We've got Wall Street. And we've got Fortune with a box around it, right? When you have 3 sets, 2 to the 3rd equals 8. That tells me there are 8 regions there. If you don't draw your box around it, you won't have that 8th region, okay? So here's what we have to do. We have to go through and label what we can label out of all of that information, all right? So here's a pro tip. If you can find the overlap, that's where you want to start. Trust me on that. So when it says 9 read all 3, you absolutely want to start with 9, because 9 is going to go in the overlap of all 3 of those circles. So put a 9 in that region. Usually you're just going to work backwards. Okay. 13 read Bloomberg Business Week and Fortune. So look at where the intersection of Bloomberg Business Week and Fortune is, this kind of football shape right there. That's Bloomberg Business Week and Fortune. And so those two regions that I just highlighted have to add up to 13. That tells me that this must be 4. Okay, we're going to do that over and over again, backwards through the problem. 11 read Wall Street Journal and Fortune. So Wall Street Journal and Fortune looks like right here, that football shape. That tells me that missing piece must be what? 2. 11 read Bloomberg Business Week, but not the Wall Street Journal. So Bloomberg Business Week, but not the Wall Street Journal means this moon shape right here, right? So you got to be really careful. Bloomberg Business Week, but not the Wall Street Journal, is that moon shape. So that's 11. That tells me the missing piece must be 7 right there. "27 did not read Fortune." 27 did not read Fortune. Okay, that one's tough because did not read Fortune would be these people and these people and these people and these people. There are 4 different regions of people that did not read Fortune, and so I can't fill that number in yet. I'll have to skip that. I'll have to come back to that. If you've got too many variables, too many missing spots, you'll have to skip it and come back. So let's go to the next one maybe. Okay, next one. 19 people read the Wall Street Journal. Okay, well, let me switch here. 19 read Wall Street Journal. Well, check it out. That's this and this and this and this. I've got 2 holes to fill. I've got 2 missing spots. I don't know how to fill in that number. I can't fill in that number unless I only have 1 missing spot. So let's skip that one. We'll come back to that. 25 read Bloomberg Business Week. Okay, now Bloomberg Business Week is this circle right here. I've only got 1 hole to fill in. I can do that now, right? I can do that. That circle has to add up to 25. Well, I've already got, what is that? 13, 17, that's 20. See how I've got 20 on the board inside that circle? So that means my missing number must be what, 5? Now that gives me my 25 read Bloomberg Business Week. And I should be able to go back to this number again and hit that number. 19 read Wall Street Journal. Well, Wall Street Journal is this circle. That circle is supposed to add up to 19. I've got 16 on the board. That means my missing spot must be 3, right? 5 plus 3 is 8, plus 9 is 17, plus 2, there's 19. Okay, so what do I have? 27 did not read Fortune. 27 did not read Fortune. Well, remember that was this and this and this and this. Those 4 numbers add up to 27. So what is that, 15 on the board? 7 plus 5 plus 3 is 15. So that means there must be 12, right? 12 out here. That's going to make my 27 that did not read Fortune. Now I've still got 1 missing piece. Hopefully I have 1 more number somewhere that I missed. Yeah, 77. A survey of 77 business students, 77. That means that all of my numbers have to add up to 77, okay? All of my numbers have to add up to 77. So if you add, okay, 77. So 12 plus 7 is 19, that's 23, 32, 37, 40, 42. That means there must be 35 right here. Okay. Once you have your Venn diagram filled out and all the numbers in the right place, now you can go back and start answering the questions. Okay. How many students read none of the publications? That's 12. That's an easy question now, right? Because we just went right here. 12. How many read only Fortune? That's this right here, right? 35. How many read Bloomberg Business Week and Wall Street Journal, but not Fortune? Bloomberg and Wall Street, but not Fortune would be this shape right here, wouldn't it? 5. 5. Okay. That's tough stuff. Got to really slow down and walk it through that question. All right. So number 7 is pretty much the same thing. So let's see if I can fit it in over here. Okay. You've got trees, poles, and wire. So it's the same thing. You've got 3 sets in this problem. So trees, poles, and wire. Box. If you don't draw the box, you don't get all 8 of the sections. So 100 workers. It's almost always going to be the case that you start at the end, the way these problems work out. But just read through them, see what you can fill in. But 10 can't do any of the 3. That means that that's outside of all the circles. 10 can't do any of the 3. 14 can cut trees and splice wire, so trees and wire, but can't climb poles. So trees and wire, but not poles, is 14, right? 14. So that means, whoops, this section right here is 14. 25 can cut trees and splice wire. 25 can cut trees and splice wire. Trees and wire is 25. That means this is 9. Wait, is that right? No, 11. "20 can climb poles and splice wire." Do you see where we need to go and how many we need to go with? What number do I want? 9 poles and wire. That makes 20 for poles and wire. 22 can climb poles but can't cut trees. 22 poles but not trees. Poles but not trees is this moon shape, right? Poles yes, trees no. So if that is 13, 13 in that missing spot. 13 right there. That makes 22 that can do poles but not trees. 57 can splice wire. Okay, well that's this whole circle, right? Splice wire is this whole circle. Right now I've got, what, 20, 34? I've got 34 showing. So this is going to be 57 minus 34. What was that, 23? It's 23. 23. 50 can climb poles. So the whole circle right there is going to be 50. I'm looking at 20, 33. I'm looking at 33 on the board. Must be 17 more. 17 inside this region. 45 can cut trees. 45 can cut trees. So that's 25, 32, 42. I've already got 42 inside this circle. I must need 3 more. 3 more. Now, I've got all my regions filled in. I didn't really need this number. Do all those numbers add up to 100? Has anybody double checked it? So you got 20, that's 33, 42, 53, 67, 70, 80, 90, 100. Okay, good. Everything's there. That's 100. Now we can answer the question. How many workers can do exactly one of the 3 tasks? Well, exactly one of the 3 tasks means this region, or this region, or this region. 3 plus 13 plus 23 is 39. Question? 13 for the only poles. When I was here and it said 50, I looked at this. Okay, it doesn't say only poles. It doesn't say only. Okay, climb poles but can't cut trees. So poles but no trees. Poles but not trees would be this. No, because that's inside the tree circle. So no, I would not use that. All right, so you good? All right, cool. It's tricky. It's tricky. You got to really slow down and be organized. Last one. Okay, this is the hardest one. Okay. Well, I'm just going to finish it. Suppose a group of 150 students have done at least one of these activities, okay, and there are, let's see, online purchase, online banking, and posted a video. So we've got three sets again, so it's pretty much the same thing. You've got a purchase, you've got banking, you've got video, you've got a box. Okay, so 10 students have done all three. That's going to be your intersection right here for all three. 12 have banked online and posted a video. So banked online and posted a video, that means there's a 2 there. That makes 12. 15 have purchased an item and posted a video. 15 purchase and video, that means that's 5. Okay, good. 70 have posted a video. So that means the entire video circle adds up to 70. I'm looking at 15, 17 already showing. That means this must be 53. That makes 70. 63, 68, 70. Okay, good. 50 students have banked online. Banked online is going to have too many unknowns, so I can't do that number. I skip it. 90 students have made an online purchase. Oops, same thing. I've got too many unknowns. Skip it. 150 students have done at least one of these activities. Well, that means inside the circle. I've got too many unknowns. When you've got too many unknowns is when you're going to have to introduce a variable. Put a variable in this overlap. Now we can go back to this. 50 students have banked online. Okay, 50 students have banked online. Well, if you notice, we've got 12 showing. So that would normally make 38 leftovers. 38 plus 10 plus 2 is 50. But you've got too much by x. So I'm just going to subtract off the x so that now it adds up to 50. In a similar way, online purchase needs to add up to 90. So I see 15 showing. It must be, what, 75 more? That makes 90 plus x. So I'm just going to subtract off x so that it adds up to 90. I don't really need, well, 150 students have done at least one of these, so that means there's nobody out here. All of those numbers should add up to 150. And so that's how this is going to work. You're going to add up all of those things and get 150. So let's add these numbers up. Those numbers add up to 183. Cancel, so you're left with just minus x equals 150. And we can solve. So let's subtract. Negative x equals negative 33. Divide by negative, and you get x equals 33. That's not the answer to the question. That just tells me what goes in this overlap. So I can figure out what goes in each of these pieces. 38 minus 33 is 5. And 75 minus 33 is, what is that, 42? Okay. How many students have made an online purchase and banked online? That would be this right here. 33 plus 10 is 43.